we are going to take a look at an idea called degree for polynomials. So we're on page 5 in your Unit 1A notes packet, and we're looking again at degree. So the other day when we were combining like terms, adding and subtracting our polynomials, as I went through each problem, I looked at adding terms, like terms, that had the same exponent, I should say, not similar, but same exponent. And as I wrote my answers, I actually started with whatever was the biggest exponent. That way I would have standard form as I went through to write my answers as I was combining those like terms. So we know for standard form, we want that biggest exponent to be first and for them to go sort of in decreasing order by exponent down to our constant term. And when I have standard form like this, that biggest exponent is what we call our degree. That's the degree of a polynomial. So degree of a polynomial is the largest exponent for that polynomial. And again, we're talking about when we're in standard form. So we've got a standard form polynomial here. The biggest exponent is 4. So the degree of this polynomial is 4. For x squared, I have a exponent of 2, and that's actually my only exponent here, but my exponent is 2. So that means I have a degree of 2. So if we take a look at a few more examples here, I do not have standard form for this next example. I can rearrange it to put it into standard form. So that would be x to the 6th plus 4x cubed plus 3x squared minus 7. Now I've got standard form. And my degree, again, is our biggest exponent. So the degree here would be 6. For my next example, we're in order, we're in standard form. My term with the greatest exponent for the variable is first, and the exponent is decreased down to my constant term. So that exponent that I see right here is my degree. We have a degree of 3. Now, if we don't have standard form, we can, like we did for this first example, rewrite our polynomial in standard form. In some cases, that's not just rearranging, but I may have like terms to combine, or I may need to do some distribution, some multiplication, like we looked at in our previous lessons. So if I take a look at my next example in this section towards the middle of the page, in order to get standard form here, I need to distribute. So I have 2x to the 4th times x, that would be 2x to the 5th. And then 2x to the 4th times -1 would be minus 2x to the 4th. I have no like terms to combine here, so I have standard form, and I'm going to look to my biggest exponent for my degree. So our degree here is 5. For our next example, I've got to distribute here. I've got to multiply these two pieces together, and then I'm subtracting 5x. So we may have some like terms to combine. So distribute, and we get 3x squared minus 4x, and then minus 5x. And I do have like terms to combine here to get standard form. So this would be 3x squared minus 9x. My largest exponent tells me my degree. So I can see here, my degree is 2. Now for our next two examples, we've got a little more multiplication that we'll need to do. So I've got 3 terms to multiply here. Remember, we only multiply 2 things at a time. So I'm going to start by multiplying these first 2 terms. So this would be x squared plus x, or 1x. And now I'm going to take this and multiply by my last term. Again, we're distributing. So this would be x cubed minus 2x squared plus x squared minus 2x. I'm going to combine my like terms here, so I have standard form. So that would give me x cubed minus 1x squared, or x squared, minus 2x. And now we can see our degree is 3, that largest exponent. For our last example in this middle section, I've got x squared times x minus 1, the quantity squared. Since I've got this thing in parentheses squared, what that means is x minus 1 times another x minus 1. So I'm going to go ahead and write another x minus 1 here. And then we've got three things to multiply, so I'll distribute just like I did for that last problem. So x squared distributed in would give me x cubed minus x squared. And then I'll multiply by this remaining x minus 1. Again, we're distributing, so this would be x to the fourth minus x cubed minus x cubed plus x squared. Again, we'll combine our like terms here. So I have standard form, so that would be x to the fourth minus 2x cubed plus x squared. And our degree, again, is that largest exponent. So our degree for this guy would be 4. Now, for the first two problems in this middle section, I didn't have a lot of work to do to get standard form, so finding the degree wasn't very difficult there. But for my second two problems, I had a few minutes of work there. I had a couple sets of distribution I had to do. I had three things to multiply together, all requiring distribution. I had like terms to combine. So it would be nice if there was a little bit shorter way that I could handle problems like these two examples. The good news is that there is a shorter way that I can handle those. If I have what we call factored form, remember for algebra 1, we called this factored form. If I have a polynomial in factored form, I can actually find the degree of that function without having to distribute. So to find that degree without distributing, I just need to add the exponents. Add the exponents. So let's take a look at that with these two problems. So remember, if I don't see an exponent, that means that it's 1. And so I have an exponent of 1 here. And then this quantity would also have an exponent of 1. That guy's an exponent of 1. So is that. So as I look at adding all these exponents, one thing I want to point out is that my x in here and the quantity, in order to be able to count that power, I would have to use the power rule, which means this one of our exponent rules, which means if I have a power to a power, I multiply those. So I would have 1 from this x in front, plus 1 times 1 is 1, plus 1 times 1 is 1. So I would get a degree of 3 there. For my other problem here, I've got a degree of 2. And then I would just have 1 here, but I had the 2 on the outside. 2 times 1 is 2. So a degree of 4. That matches what we got when we distributed. That would also work for this guy. I have an exponent of 4 and then an exponent of 1. 4 plus 1 gives me a degree of 5. I could not use adding the exponents here because this guy's not in factored form. I have that minus 5x here, meaning this is not factored form and it's not standard form. It's sort of a weird in-between version, so I've got to go ahead and distribute on this guy. But let's take a look at a couple more examples where I could just add the exponents. So for my first example in this bottom section, here's an exponent of 1. This would be 1 times 3, that's 3, and 1 times 2, that's 2. So 1 plus 3 plus 2 means I have a degree of 6. So my degree here is 6. For my next example, 1, 1, 1, 1 plus 1 plus 1 would be 3. Notice I didn't care about the exponent on the 1/8. I only care about exponents on factors that have an x. So I have a degree of 3 here. For my next example, I've got an x squared, which is the one outside here. 2 times 1 is 2. Again, same idea here. So I would have another 2, and I get a degree of 4. And then for our final example, my x has an exponent of 2, and then my quantity also has an exponent of 2. So I need to use that exponent rule that says I multiply those powers. So our degree here is 4. Okay, so that's the degree of a polynomial. We're going to use degree next week when we talk about end behavior, how we determine the general shape of a polynomial without actually having to graph it. Degree is going to be an important component of being able to determine the shape of a polynomial.